All right. So it's 4:05 and March 10th. So yeah, there's a little I guess it must be section C. So anyway, one of the calendars that's posted had assignment 3 listed on Monday. Yeah, I believe it's the next section, Tuesday section. So I extended it for a day for that, just in case students were confused. So assignment 3 is technically due tonight, with a late deadline of 8 a.m. Don't miss the late deadline because that's 0. But other than that, your assignment 2 marks should be out. All right, I'm getting a lot of emails about people who submitted the wrong files or empty folders, and at this point, I can't do anything about it. Right? If I do that, essentially I open the door for everyone. And we don't have the TAs to mark assignment 2 and 3 and test 2 at this point. So please, when you submit assignment 3, download the files and double check to make sure you submitted the correct ones. Right? Things like last modified, those are easy to fake. It's easy to change. So assignment 4 is not out yet. It should be out sometime this week, along with tutorials 8 and 9, and that'll take us to the end. Test is Wednesday, and I'm going to start the class by reviewing the practice test, right, in great detail. So any questions before we get started? Okay. All right, so so this is the practice test, and it does not have any general knowledge, true or false practice tips, because there are no general knowledge questions on this test. I'm going to give you a code base. It looks a lot like this one. It's not this one, but it's very similar. Right? I mean, there's a 1,000 examples that I can use of some sort of entity class, and then so my entity class here is derived class called a premium movie, and I have a movie array which holds movies or movie pointers more specifically. And this is this is the throwback to assignment 2, right? So we have a dynamically allocated pointers. So I'll go into great detail about how we use that. I mean, essentially, as mentioned, this focuses more on the assignment 2 stuff. If I put assignment 2 and 3 together, it's a lot of material. So the way that I structured the test this semester was sort of experimental. It didn't really pass the experiment. It's not a good division of material. So, and then we'll talk about movie flicks. So it's basically, I have an entity class and maybe some subclasses. I have a collection class, and I have the control class. How do they work together? And with an emphasis on memory management, right? So correct pointers, correct memory, stuff like that. And all questions, there are some programming questions and 2 multiple choice. The multiple choice are worth 2 marks each. And the multiple choice are also related to this code base, right? It's like, which of these functions is correct, sort of thing, or the correct implementation. All right, so I put this code, not quite this code base. I made a couple errors, right? I think I mentioned print movies on sale. Well, that says print all movies whose on sale function returns true. Well, there's no on sale function. I did not include one. So we're going to, so I posted this code, not quite this code, but very close, to Brightspace under the tests. So next to the practice quiz, there is this code base here. The one that you see here. And so we're going to go through, we're going to write a bunch of these functions and talk about how it is structured. So start with, we have our movie class. Now, instead of, I'll get to that later. So there are some implementations here. I'm not going to require you to write any of these implementations, but I need these here to test it out, right? So we have a virtual print function. We have a virtual play function, which is just like print. We don't have any video data to play, but like, we could pretend. We have some private member variables, and we have a constructor. So we're going to write enough functions basically so that we can test these things. And the tests are down here. So to start with, we're going to make some movies. We're going to make a regular movie and 2 premium movies that you have to pay for. We're going to print them all out and make sure that that works. But to do that, we need the premium movie constructor. So if we look here, know how to write the constructor of premium movie. Right? There's a very good reason why this particular sentence is there. Know how to write the movie array functions. We'll get to that. But first, we need to be able to make a premium movie. So let's do that. So we have a constructor for the regular movie. It initializes title and runtime. Title and runtime are private member variables. And so in my premium movie constructor, I'm going to do the following. So, well, the first thing, of course, price is private to premium movie, so I can definitely initialize price, right? Using member initializer syntax. I don't have to use that here, but this does work. The other thing is I have to initialize from my parent title and runtime. They're private to the parent. So I cannot access them directly. I have to call the parent constructor. The parent constructor, there is no default constructor. So, I mean, I would have to call it regardless, right? It says, expects that identifier, sure. So I'm going to call movie and then pass in, what is it, title and runtime. Runtime. Okay, so that's it. The big or sort of the key point there is that I have to call this using the base class initializer syntax. That's it, though. I don't necessarily need to do anything in here. Questions? Okay, so for this to run properly, I'll have to write implementations of these. I'm going to ask you to write implementation of these, right? This is, I'm only going to ask you to write this constructor. As far as these go, you should know how to write them, but I won't ask you to. I want to print my premium movie, but I want to print it just like a regular movie, but add the price. I can't actually use this code because title and runtime are private, but I can call the print function, which I did. And then I could say price. And this play, we don't actually use it, it's just for show, but I do, the compiler will get mad at me if I don't override it. So let's just put a little fake code in there. And now I can make movies and print movies. Questions so far? Okay, so that means my little bit of code here should run. I think, let me comment this out. So yeah, in terms of studying, this is sort of what I recommend, right? So take this code. You have you have this code and just write these functions and make sure you understand how to do that and check with valgrind every time you do something to make sure that it's running correctly. So I don't have a make file, so -o. All right, so printing movies, Titanic at 100 minutes, Titanic 2, and Aliens. I didn't delete them, so there'd be memory leaks at this point, but we will fix that in a second. Questions? Okay, movie array. So I want to be able to add these 3 movies to my movie array and print them. And to do that, Well, we're going to have to write some movie array code. We're going to have to write the constructor, probably the destructor, maybe the copy constructor, definitely add movie. Oops, sorry. Constructor, destructor, add movie. So we're going to write these ones. Movie array. Yeah. Okay, so here I have, let's talk about what movie array does just to make sure that we have an accurate memory model going on. So I make a new movie array object somewhere, maybe inside movie flicks, maybe by itself in the main function. Inside of it, I have a movie double pointer. And what I'm going to, and also a size, which, we're less concerned with. What I'm going to do is I'm going to make a backing array on the heap, and I'm going to point that pointer to it, the double pointer. And the backing array is going to hold movie pointers. And then, so when I add a movie to the movie array, what I'm going to do is, well, first I'm going to make the movie, new movie, and put it on the heap. And then I'm going to assign that memory address. I'm going to add the movie pointer, and I'm going to end up with something that looks like this, right? So my movie array points to a dynamically allocated array of movie pointers, and those will point to movies that I add. Okay, this will be important as we try to figure out what to do with the destructors and the copy constructors. Questions? Okay. So obviously I need to make a new array. So movies equals new, and it's an array of movie pointers, and it has size max array. And of course, size equals 0. And oh, there we go. All right, so that's our constructor. We've made the array. We haven't added any movies. We have size of 0. Probably we want a destructor as well, and we'll figure out how to manage that. Now I'm going to do 2 different things for the destructor, so please don't get confused. But I'm going to start by deleting all of the movies in the destructor. And then later we're going to change that. But one thing we definitely have to do regardless is delete the backing array, right? So this guy here, that call will delete that. And then if I loop over everything and delete everything in the array, then it'll also delete any movies that it's holding, which we're going to do for now. Okay. All right, questions? Wonderful. All right, so, and now let's make the add bool movie array. Now, I think the instructions are to add it in order, by order defined by the less than. But I'm just going to do something really simple. All right, so yes, add the movie in order as defined by movie less than. Okay, I don't want to do that because it's too much work. You should understand generally how to do it, right? If I have a backing array and I want to add something at a particular location, A, B, D, E, and I call add C, and it's the less than function defines alphabetical order, then I know that C has to go here, and basically I'll want to move things out of the way, right? So I want to copy E over 1, and then I'll want to copy D over 1, and then I'll add C right there. So you should kind of maybe understand that generally, but I'm just going to add to the back, which means that, well, in this, Well, the first thing I'm going to do is a bounds check. I'm going to say if size is greater than or equal to max array, return false, right? For any of these functions that you write, a bounds check is 1 mark. Okay, so don't forget to do it. So this would be 1 mark if I ask you to write this function, and then I'll say movies. Well, the way that the size variable works, the size contains the number of movies in my movie array, and it just so happens, because we start counting at 0, that it points to the next empty location in my array. So I'm going to say, well, that is equal to m, and then I'm going to say, well, increment size, right? So we've added 1 movie, so now size is 1 more. And so yeah, this is a very simple version of add. It'll be good enough for us to test from. And then get. If I want to print things, I'll need to get them. So let's, right, we're just doing sort of the minimum required in order to test this out. Get. So if, again, bounds checking is 1 mark. So if index is less than 0 or index is greater than or equal to size, I will return. Well, I'm returning a movie pointer, but I don't have a movie pointer to return, so I'm going to return a null pointer. This, I'm guessing, is const. And well, the range is valid, so I'm going to return movies, or sorry, the index is valid, so I'm going to return that. So yeah, that's the get function, right? Bounds check, return the thing at the index. Okay, so we've written presumably enough functions to be able to run the next few tests, which is I'm going to add 3 movies to the movie array and then print them out. And just to make sure that, yeah, not to clutter our space too much. Yeah, I forgot to return true probably. So adding movies to the movie array and printing. So Titanic, Titanic 2, and Aliens get printed. And at this point, movie array gets deleted when I leave this function, and it should call the destructor, and that destructor should delete all of these movies. So I should be able to run this with valgrind also. And yeah, so no leaks. All right, so so far so good. Question? Okay. Remove. Do we really need remove? I guess let's do remove. I am going to quickly write the remove function, right? So remember how when we added, we were supposed to copy things to the higher index in order to make room. When we remove something, I'm going to grab that pointer. I want to return it, but I'm going to copy things over. So I'm going to copy things from higher indices to lower indices, right? I'm going to close the gap. So, right, if I called remove C now, well, I'm going to take C and, well, C is a memory address, but I'm going to take a copy because I want to return it. And then I'm going to close the gap. I'm going to say, well, copy D over here, and then copy E over here. And then I can leave this E here, and I'm just going to decrement size after that. So I'm going to do that really quickly, or at least try to. I need a, okay. As usual, bounds checking is 1 mark. Now I want to, let's see here, for int I equals size, no, sorry, index. I is less than size and plus plus I. And then all I want to do is, well, actually, sorry, the first thing I want to do is grab the movie that I would like to remove. Honor equals movies at I. And then I'm going to close that gap. So movies at I equals movies I plus 1. Sorry, index. All right, so this is, now there is an off by 1 error here, right? Because if I look at the value of I, it's going to go from index to size minus 1. And at size minus 1, I plus 1 is equal to size. So I'm copying, and there's size is the next empty location. So in the last step of the loop, I'm actually copying the empty location, the last empty location over the, and I mean, it's this wouldn't even cause an error unless my array was full. But if I happen to ask you to do something like this, I'm not super worried about these off by 1 errors. I am more looking to see that you copied things in the right direction and in the right range, right? So from index to size, give or take, and then copying the higher location into the lower location. But yeah, that size minus minus, return goner. Questions? What are the odds this works on the first try? I'd say slim to none, but let's try it. We're going to remove a movie. We're going to print that movie, and then we're going to print the array and see if all of that works. Oh, look at that, not even a segfault. Okay, so removing movie 1, printing the removed movie was Titanic 2, and then printing the movies that are left in the array, Titanic and Aliens. That actually works perfectly. I should be able to write it with, run it with Valgrind as well, and no memory leaks because we're cleaning up after ourselves. Okay. Let's do that whole thing again, but now I'm going to remove, I'm going to make this other remove function, right? Remove by title. Okay, so const string and title. Okay, so I want to find, well, first I have to find it, right? So int, I'm going to traverse the entire thing. I is less than size plus I, oops. Okay, and then if movies at I, that returns a pointer. And now the movie has an equals function that happens to take a string or a title. So we're gonna use that. It may also have a getter, which would be, you know, we could use that as well. If this is the movie we're looking for, then what? Well, I know the movie, I have the movie, I'm gonna grab it, you know, goner equals movies at I, and then I'm going to do a for loop to close the loop, and then I'm going to decrement size, and then I'm gonna return goner. In fact, I'm gonna do all of this. The only thing I'm not gonna do is the range check, but you know, if I don't mind paying a little bit extra for the range check, then why don't I just do this? Return, remove, I. Right? And then, so that function's really simple because this does all the work for me. It closes the gap, it decrements size, it returns goner. So this is good. Questions? Okay. Let's try it out, I guess. We will remove aliens. We will print aliens, delete it, and then print whatever's left in our... Oh, I keep forgetting to return. I'll fix that later. Okay, so removing aliens and then printing it right there. And then the only movie that's left after we remove Titanic 2 and aliens is Titanic 1. And I can run that all with Valgrind. And yeah, still no memory leaks. Good. All right. So now we're up to movie flicks. Okay, so I've basically written and tested my my movie array class. I've not done everything, but I've done enough to like get some functionality. So let's try movie flicks now. To do movie flicks, I'm going to get rid of all of this stuff. Let's start fresh. Make movie flicks. Movie flicks account belongs to Bob. I'm going to add those movies and then print them. So these are the two functions I want to write for movie flicks. But I also need a constructor and probably a destructor. So let's do that. What's up here? Okay. Subscriber. Right, so member initializer syntax. Again, you don't have to do it. You could say this subscriber equals subscriber. So we've initialized this one. We just have to initialize this. This is just a pointer. So in this case, I'm going to say movies equals new movie array. I might, on the test, this might not be a pointer, right? Maybe I just say movie array movies, in which case you don't have to do this, right? If this is statically allocated, then it's automatically made for you. But we'll stick with this for now, and then we'll also write a destructor. And delete movies. At the very least, we have to do that. So we called new here, we called delete there. We're going to call add movie. Or we're going to write it. Now inside add movie, we're just going to be, we have a movie array. We really want to just make the movie array do all the work. Movie array.add returns a Boolean, and it functionally does the same thing that we want our Boolean to do. So add M. So this is really easy, right? So add movie, I'm just using the collection class and all of the stuff that's already written for that to do the thing that I want to do. And spider. And then print movies so that we can test all this out. Oops, print movies. And this is const. Okay, and then, well, simple for int I equals 0, I is less than. All right, now we have to use our movie array instead of the primitive. So get size and then plus plus I, and then movies get I print. All right, so these arrows are important. They're not pass or fail important. They're like half a mark important. Okay, so make sure you, if it's a movie point, like movies is a pointer here, which means that if I want to call a function, I use the arrow operator. And this get I returns a movie pointer. So if I want to call a function, again, the arrow operator, right? Half a mark. But easy half a mark if you remember. All right, so now I have enough to do this. So this should all work. Someday I'll remember to fix that. Generating and printing movies, Titanic, Titanic 2, and Aliens. So they all work. We can try with Valgrind and it should work. No memory leaks. Okay, so that's good. And we're basically almost there. This print family movies, I'm actually going to change it because this is, you should know how to write a print family movies, right? So what I'm going to do is I'm going to loop through all of the family movies and just apply the predicate. And the fact that, so family movie, if we look at our movie-based class, is it a family movie? It's a family movie if the runtime is less than 120. Now, the specifics of this are not super important. What is important is that an entity class might have what's called a predicate, which is just something that returns true or false. And then based on that, I'm going to filter out some of the movies, right? So is it a family movie? Yes. If so, then print it. So print family movies. And then in here, I'll say if movies get I is a family movie, then, well, that's it. That's the only difference between print and print family movies is that I apply this little filtering if statement. Okay. Sorry. And so, yeah, it prints out, I didn't demark it, but this is the original print. And then this is the print family movies, the 100 minutes and 99 minutes. So that's, all right. One more thing we're going to do is, well, maybe instead of print family movies, this is called get family movies. Okay, here's where I'm going to change the destructors, right? So everything's working fine right now. We're deleting all the movies in the movie array class. We're deleting the movie array in the movie flicks class. So everybody's responsible for their own thing. I'm going to change this to get family movies and say, well, what happens if I pass in a movie array? We'll take that off just for fun. So this is now get. I don't think the const will make a difference, but just the fewer issues I get, the better. All right, so now this is an output parameter. So get family movies. Again, I'm going to loop over everything and say, well, is it a family movie? If so, instead of printing it, I'm just going to say ma.add movies get I. Right, so this is an output parameter. And what am I doing exactly? If I look at my memory model, it looks something like this. Well, I'm passing in a second movie array. That is, I'm getting all the family movies and putting it there. And so this has a pointer to some array of movie pointers. This is all on the heap. Actually, the movie arrays are also on the heap, but that's not a huge problem. And then I'm looping through and I'm saying, is this a family movie? Is it yes? Well, then copy this pointer to here, which means that this points to the same movie. And then I'm going to say, is this a family movie? If so, then copy that pointer to there. Now this is pointing to there. So I have my movies that are in both lists. both arrays. And if I delete the movies in my movie array, when this goes out of scope or I call delete on it, these will be deleted. And the movies from my original movie array will be deleted. And I have memory problems, right? We did an example like this with university and students who were on the honor roll, right? So we had an honor roll list, and when we added students to the honor roll, if we deleted them, that caused problems because now our honor roll students were deleted from our main list. So two solutions to this. I'm going to give you one though, and then I'll briefly talk about the other one. I don't want to confuse anybody. Here I'm just adding the pointer. So I have it's this diagram. So I do not want to delete in my movie array. I want to delete in my movie flicks. So the movie array is still going to delete the movie backing array, but the movies themselves will be deleted here in this. Delete movies. Okay. Now, if I didn't do the thing where I shared the movies between those two arrays, then this or the other one would work fine, right? These are both valid ways to delete all the movies. But because I have this output parameter, and then that means I have movies that exist in two different arrays, that means I really have to do this, okay? Print family movies, yeah. I'm not gonna, sure, let's test it, I guess. Let's make a movie array. Family equals new movie array. Then get the family movies. And then print them. Well, and then delete them. So yeah, I deleted that for loop. Okay, so for okay, and this should, with fingers crossed, this should work. So see out. Family, geez, whatever. All right, just to separate out the family movies. All right, so printing family movies, Titanic and Aliens, both great family movies. And if I'll grind it. Ah, look at that. Well, I got very lucky there. Usually coding this fast, I messed something up. But all right, questions. Okay, so in terms of the memory model, I got to delete my movies somewhere. I either delete them in the movie array or in movie flicks. Now, if my movies are shared between multiple movie arrays, then I should delete them in movie flicks. Not, then either of those is valid. The other thing you can do is this, right? All right, so that is the recommended. If this is already confusing, just stop there, stop listening. But here, there's another way we can do it. If I really want to delete things in my movie array, then I just do a deep copy here. I just say new movie. Don't let that confuse you though, okay? We're going to go back to this one. All right. Finally, so delete family, yes. We're going to make a second movie flicks, and I'm going to make a copy of that original movie flicks. So now I want to make a copy constructor, and I want to make a deep copy, right? So deep copy means, well, if I forget about my family movies now, this movie array is inside a movie flicks object, or it's a, I mean, there's a movie flicks, and there's a pointer to a movie array that actually also exists on the heap. So this is an accurate memory model at this point. So I want to make a copy of this movie flicks. In this case, it's also on the heap, but that's sort of immaterial. It's going to have its own movie array. This movie array, of course, will have its own backing array. And if I want to add these two movies, I'm going to make copies of them. So I'm just going to expand my heap here. And so I say, well, I'm going to loop over the original movie array and said, take this movie and make a new movie from it. M1 and M2. So I make a copy of M1 and then I add that to my movie array, and then I make a copy of M2 and so this is the picture I want to end up in. So there's a bunch of layers. I have to make sure that each of them gets copied correctly. But I've, yeah, questions so far? Okay. So let's write this copy constructor so that we get exactly that. Take this. Movie flicks copy. Okay, well, this is actually okay. I need to initialize the subscriber, but I want to copy that from my movie flicks copy. This is also okay, right? This is what we want. And so new movie array just creates this and creates this. So that's okay. So far, so good. Now we just want to loop over this movie array here, loop over every element in this and copy the movies that it points to, and then assign them to this. It's a little bit tricky, but it's not as hard as you would. Well, I'm going to write it all, yeah, and then we'll try and walk through it. 0, I is less than copy dot movies dot, oops, copy dot movies get size. Right, so this is the movie array inside this copy, the get size variable. Now, let's break it down just a little bit. Movie to copy, you can write all of this in one line, but I'm going to expand it out and maybe it'll make more sense. I don't know. So this is the movie to copy. This is a pointer to the movie that I want to copy. And then I'm going to say, well, I want to copy it into my movies array. Movies dot add new movie. And then I want to copy this guy. I need to dereference it. And this is, sorry, minus 0.5 for me. Okay. I don't know if this is useful to break it down into these steps, but this is basically what you want to do. It's a little tricky now because I have my copy and I'm going into my copy, I'm getting this member variable, and then I'm calling functions on that, right? So it's these two layers of objects before I get to the movies, which is the third layer. But I guess a rule of thumb is that if I'm making deep copies of movies, you should have new movie in here somewhere. If you don't, you're not making a deep copy, okay? These movies are on the heap, so I want to call new movie. And I have a default copy constructor that I can use, so the fact that there's no explicit copy constructor is not a problem. This should work. There is one problem that I didn't notice until today, but let's try it out. So we're going to make a copy. Let's just get rid of this stuff. Don't care. I'm going to make a copy, and then I'm going to print out the copy. So let's say printing flicks copy. Put a couple blank lines and call print movies. See if that works. Okay, generating and printing movies. So I added them to MovieFlix and then I printed them out, and then I printed, the spacing's terrible, but I printed the copy and I got 3 movies. This not quite the same, is it? Anybody spot the problem? I messed up slightly. So the problem is, if you look at it, I wonder, sorry. Print movies. Let's just add a little bit of formatting so we can get a better sense of what's happening. Okay, so generating and printing movies. The first movie is Titanic. The second movie is Titanic 2 with a price of $10. This is the original MovieFlix. Now I made a copy, and you'll notice Titanic's okay, but Titanic 2, there's no price. And Aliens, there's no price. Why is that? One little thing. I was trying to like get a little bit of assignment 3, and then I forgot about this thing. So what did we do when we made a copy? New movie. Some of these are premium movies, but I am copying them into a regular movie, right? So the premium movies have a price, but regular movies do not. Why is that highlighted? I don't know. Sometimes, okay. Sometimes for whatever reason, Windows subsystem for Linux messes up, just like I did here. So I made a copy of movies. So with polymorphism, copying things is a little trickier, right? Because like, how do I know if it's a premium movie or a regular movie without actually looking at the thing? So for the test, this is a correct answer. That's what we're going to accept as a correct answer. There is a slight problem with this answer in that the premium movies are copied into regular movies, but that's a little deeper than we want to go here. I will show you how to fix this, but this is the correct answer. This is the answer that you will get full marks for. Questions? And this would work if I didn't subclass movie, right? So making a copy with polymorphism is a tricky because if you have a movie and premium movie subclass, how it copies? Yes, virtual clone function. That is how you would do it. But I didn't put a virtual clone function here. So on the test, if you want to add one, right? If you run into this scenario and you want to add a virtual clone function, knock yourself out. But we will accept this this not quite correct copy constructor because it does sort of most of the stuff right. But yes, so if I wanted to, that is the problem with copy constructors, is they are not polymorphic, right? They are for whatever specific type I call it on. So I need a polymorphic function. I would say virtual movie, clone. And in here, I just make a new movie and return it. And this, so I would say, return new movie, this. And then I would override that down here and say virtual clone, return new premium movie, this. And I will appeal to the person in the chat. If you see a mistake, let me know, because I did not test this. So I'm just I'm winging it, and I could have missed something, but I believe that this is it, right? So I returned a premium movie, which is being held by this or pointed to by a movie pointer, but that's fine. Underneath, it's still a premium movie. So yeah, and then down here, where is it? I would call clone on this this copy. But whatever. This is fine the way it is here. I don't, sorry to, like, if this is confusing you, just forget about the clone stuff. Just do what you see here. Well, I should be able to delete this copy. It should go through and delete all of the movies that it holds. And then I should be able to print the original movies. And all of that should work while so no seg faults, no double freeze. So printing after deleting copies. This should, yeah, sorry, no seg faults, no double freeze. I should also be able to run it with Valgrind. P1. And yes, that all does work. All right, so that roughly speaking is what you should understand for the test. So I'm going to ask you to code some of these up. There will be the simpler ones, except for this. I will ask you to code the copy constructor, and it's probably the longest and most complicated thing you're going to code. All right, everything else will be simpler than that. I can ask you for constructors. I can ask you for destructors, right? These are just a couple lines, but you have to sort of understand what you're doing. And you should understand how the movie flicks destructor and the movie array destructor work together to delete all the movies and make sure that your memory works. And know how to write the constructor for the, well, in this case, it's premium movie. Again, yours won't be this. It'll be something very close to it, though, in terms of structure. So you'll know how to write this constructor. I'm giving you a lot of information because, quite frankly, there's 3 sections, and the tests are not that different. So I'm basically just giving you everything. Because otherwise it's not fair to the people who write first, right? Which is the previous section. But you guys are writing shortly after, so this is everything you basically, I'm giving you a lot here. I'm giving you basically everything you need to get perfect if you just study and understand it. All right. If you want to implement the movie array copy constructor and use it in this copy constructor, you are okay to do that. Just make sure you understand what you're doing. All right. But yeah, questions? Is that a question? Yeah. Oh, I mean, I just tried to make it look good. You should, I mean, this is just a getter, right? So you should be able to write that. This is not, so get download, what's that? It's like a fake download. I don't know. This is just, this movie essentially. I just put down, I don't know. I was trying to make it sound more authentic. Yeah, so there's nothing here that, right? I've shown you everything. Like, yeah, this is get movie. That's it. Yeah, I would call the play function, right? So I would find the correct movie with this title, And then the movie function has a play. In this case, it doesn't do anything. Yeah. But yeah, those, like if you called print in there, I would consider that a minor error, you know. I've emphasized sort of the things that I'm interested in you getting correct. And yeah, if you substitute play for print, it's fine. Uh, okay. So I guess we'll pick up where we left off with operator overload. You can add getters, generally speaking. Um, it's better not to. Generally speaking, you get everything you need to, right? It's like adding a copy constructor. Well, you get a default copy constructor. So you don't really need a getter to make a copy. But yeah, better that you add a getter. If you think you need one, add one. Okay, that's better. I'd rather you write some code that works and break the rules a little bit. But you shouldn't need it. And I say that with knowing full well that there might be some error that where you actually would need it. So, you know, hopefully not, but it is possible. So we left off, yes, we were talking about the stream extraction operator. All right, so find that. And the stream extraction operator is an example of an operator that can only be overloaded as a global function. Because if I say something like cout the time, well, my left-hand side parameter is an OStream object, and I don't have access to the OStream class so that I can add a member function. I only have access to the time class, so I'm going to have to add a global function and then pass this in as a parameter. So that's what we did, right? If we look at, yes. So if we look here, well, this is the stream insertion operator, and it looks a lot like the print function because we want it to behave exactly like the print function. But we're passing it to this stream, which might be cout, or it might be a file stream, or it could be any kind of stream, right? So this is a lot more flexible, but the formatting is the same. All right, so let's 15. Okay, so time now is 13, 12, 22, and then we print out the now. Then we have this other thing which we're going to handle next. So stream insertion operator overloaded as a global function, and we make it a friend of our class because it's an honorary member function, right? We can't make it a member function because OStream is the left-hand side operand, but we give it all the privileges of a member function by making it our friend. All right, so now now that we've written out a time using the stream insertion operator, we're going to use the stream extraction operator to ask somebody to enter a time and just read it automatically into my time object, right? So, and it's like, sure, maybe this is not the best use case where I enter manually a time, but maybe it is. But this is great for reading from a file, right? I can specify, if I know the format that I've written a bunch of my time objects to the file, and I can just read them in using this operator. But from here, we're going to do it from the command line, and we're going to put our time in this format. All right, so the same thing we did before, except now it's we want to make it a friend. It's The left-hand side operand is an iStream object, but it is an honorary member function. And then all right, let's try that. Shout out if you see any problems arising. This should, yeah. So the compiler's happy now. It says, oh, I have a friend that will do this for me. The compiler hasn't even seen this function, but it believes me. iStream. iStream. Okay. Now, essentially what we want is we want to read, well, I'm going to type in like something like 12, 22, 44. And then I want to parse that and put the 12 in the t.hours and 22 into t.minutes and 44 into t.seconds. Okay, so I can do ist, grab whatever's there and put it into t.hours. And well, there's a couple problems. What is this problem? It's inaccessible. That's not true. Should be fully accessible. What did I do wrong? Aha. Okay. And then I kind of want to do something like this. t.minutes, ist, t.seconds. But of course, this is the format I'm looking for, and there are these pesky little colons here. So I want to read in numbers until I hit something that isn't a number, and that's what will happen here. But then I want to throw that one character away. So I'm going to say ist.ignore. That's a little function that just throws the next character away. And then after minutes as well, ist.ignore. Okay. So now I should be able to read something that looks like this into my time object. Compiler's happy. And then we'll print it out. And yeah, let me always forget to return this thing. And normally it's not a problem, but I think the latest version is slightly different, and now it crashes when I do that. But this also crashed. Anybody know why? So it has something to do with what I did here. Or I guess, I mean, all the information you need is there. So what is it? I mean, I'm really surprised actually that this compiled. That kind of surprises me a bit. So I'm taking characters from this stream. I'm converting them. If they're a number, I'm converting them to an integer, and then I'm assigning that integer to this integer. All right, so in this case, it was 12 maybe, and then 12. So I'm saying t.hours equals 12. But my t is const, right? So I'm saying, please modify this variable. And here I'm saying, you're not allowed to modify that variable. Right, so I'm really, it's kind of weird to me that the compiler didn't catch it, and it actually waits until we get a seg fault when we try and run it. But yeah, the input stream operator is actually slightly different in that, well, I do want to modify this thing, so I shouldn't make it const, right? Here I'm only reading it, so I don't care. I can make it const, that's great. But here I'm actually writing to it, so this should not be const. And then hopefully that that will work. Take your time. All right. P5. Enter a new time. What is it? 5:05, 10, 22. And the new time is 5:10 and 22 seconds. All right. Questions? Okay, so for your assignment 4, this you should do for basically every class that has a print function. You'll want to do this instead. This, I'm not sure if it's going to be featured on assignment 4 or not, but it's less common, right? This is more, I would use this more if I'm reading and writing from a file. Then I would overload this, but definitely you will be doing a lot of this. Okay, which brings us to the next thing is that, okay, so the stream insertion operator takes 2 operands. The left-hand side operand, well, in this case is cout, but it can be any kind of output stream. It's an output stream object. And the right-hand side is the thing to be output. And we probably want it to be a friend of our class. The stream extraction operator, same thing, takes 2 operands, but in this case, the left-hand side one is the input stream. And the right-hand side is the object to be input, should not be const. We are planning on making changes to it. Also, we want it to be our friend. Okay. Polymorph with this thing. So we saw what havoc it could wreak with our copy constructors. And it turns out when we try and do this host stream with polymorphism, also kind of a pain. But there is an easy solution. So class hierarchy, we have an animal. We have a bird as a derived class and a chicken as a derived class of bird. And so what we're going to do is we're going to make a bird and a chicken. And well, to start, let's just print them out and see what they do. All right, so big bird says tweet, tweet. The bird says tweet, tweet, and the chicken says cluck, cluck. Right, so that's the behavior that we expect. But now we want to print it out like this instead. So we are going to need to overload some sort of operator. So the question is where? We do it for animal or for bird or for chicken? Well, let's do it for bird really quick. Operator. Bird's nice sitting there in the middle between chicken and animal. So let's just take this. This will be the output stream. Bird.name. Oh, it's fine with that, is it? So yeah, and then we got to make that a friend of ours. So friend. Okay, so we've got something that'll print out a bird, and then we can also apply that to the chicken and see what happens. And to absolutely no one's surprise, they both say tweet, tweet. Okay. Well, that makes sense. I mean, that's what we have here. So how do we get polymorphism out of this? Also, what happens if we do this? Well, I have an animal pointer now that points to a bird and an animal pointer that points to a chicken. And this is just a function and it's looking for an animal pointer, right? So I need one of these that takes an animal pointer. So, well, let's do that. Animal, and then just say animal speaks. And let's take this. We no longer need that. We'll put it in the animal class. Of course, the problem now is this works, but everything just speaks like an animal, right? So I don't have polymorphism. All right, so every time we run into this problem, the solution is basically the same. It's another layer of indirection. With the copy constructor, it was the clone function. Here, we're gonna reuse the print function, actually. We're gonna say, well, let's just, instead of printing to the standard output, print it to the stream, right? Full stream. And then this print function is a virtual function and does have polymorphism. So, well, then in here, I'm just going to say, take my animal called Al. Just say al.print to the output stream, and then return the output stream. Okay, so that one little layer of indirection means now that, well, this is a global function. Like, I cannot make it virtual, right? There's no such thing as a virtual global function, only member functions, only in a class hierarchy. So, but this print function is a virtual function, right? So it's going to call the correct print function based on the type, or at least that's the idea. All right, so now Big Bird says tweet, tweet, the chicken says cluck, cluck, and even with the animal pointers, it does the same thing. Okay. So for your assignment 4, I am pretty sure I know what I'm going to give you. I'm not 100% sure, but most likely you will see this. You'll have some class hierarchy where you have to implement this using polymorphism, and it's this easy. You just reuse the print function. Okay. Questions? All right, 8 minutes. Oh boy. All right. Or what if there's a okay, well, we'll do this. Let's talk about this. Maybe we won't dive completely into the code, but let's talk about sort of what we've done with operator overloading so far. So we've seen something like this where we wanted to say enable cascading in the time function. I say set hours, right? Something like that. And then, sorry, int. So then I might have a time, and then if I do the same thing for set minutes and set seconds, then I can have, time.set hours to 5.set, and I'm out of space, but set minutes, blah, blah, blah. So I can chain these things together. And so for operators, we want to enable cascading. Essentially, any time an integer would do the same thing, right? And so we've seen examples. In particular, we saw this equals operator. At the end of that, we want to return the this object, and we want to return it by reference. So when in doubt, return this by reference. But it turns out that's not always the best way to do things. So if we are looking at these two operators in particular, well, if we look at this, let's say we chain this together with integers. And so the behavior is that, well, C, I'm going to take the value of C, I'm going to add A to it, and I'm going to store that back in the C variable. And then I'm going to return the C variable by reference, and that will get assigned into the D variable. I can also return it by, we could think about returning it by value, I suppose, and think about what the consequences of that would be. But let's look at this operator now, the plus operator. So here I'm going to add A and B together, and I'm going to take the result and I'm going to assign it to C. Now, A and B are not supposed to change, right? So So what does that mean in terms of what should we return? We can't return anything by reference, because if I return A, well, that's not A plus B. And if I return B, well, that's not A plus B either. So we have to make, well, we're going to make a temporary variable and well, let's talk about that. 5 minutes, eh? Not a lot of time, but we can get started. Okay, so well, here's our operators, I guess. So this is our time class. We have, I guess I was fooling around with this a little bit. All right, so we want to implement this plus equals operator, and the key is we want it to behave like, see this big spoiler alert here. We want it to behave like ints. So we're gonna return by reference. Yeah, and we're actually adding an integer too, eh? All right. So here is the code that we want to work, right? In our test development again. I want to be able to say, well, I'm gonna have lunch at noon, and then, well, I'm gonna say, well, actually, let me add 80 minutes or seconds to that, right? So I'm gonna say lunch plus equals 80, and then I'm going to print out the result, 80 minutes or seconds, it doesn't really matter. Probably seconds, I guess. So, well, let's implement that. Well, spoiler alert, we're gonna return by reference, but int t, okay, so this is a time in seconds, and we want to add that to the current time and have that changed. So we have this set time that's going to take the number of seconds since midnight, and I'm going to set the current time to it. And if we look at how that works, it uses integer division and modular arithmetic, right? So this is, well, I divide s by 3600, and it's integer, so it doesn't give you back a float. It just drops the remainder. And then this gives me the remainder of s divided by 3600. And then I see how many times I can find 60 seconds in those. And then I do the same thing here. Yeah, anyway, if you have any questions about that, we can figure it out later, but we can use that to say int time equals convert to seconds plus t. And then I'm going to say set time t, time. And I'm going to return this, right? And that should basically enable cascading, which we'll look at in a second, but it's also going to change my current time. Okay, so lunch initially at 12, we add 80 seconds. It should be 12:01 and 20 seconds, and then we print it out. And maybe we will lunch before I add 80 seconds is 12. Lunch after I add 80 seconds is 12:01 and 20. And I could also do, because I've enabled the cascading, I return the lunch object. I can add another 20 seconds to it and print it out at the same time. And then, so these should both print the same thing if we're doing things correctly. So I add another 20 seconds, I get 12:01:40, and here 12:01:40. Okay. All right. I think we're going to stop there today. Next week, I guess, we will continue. And yeah, so the test, just so everybody, I guess the question is inevitable. Can we have the solutions? And I will think about it, but I would say assume no, right? Because I would prefer that you figure these things out for yourself rather than just memorize them. It's not that memorizing is a terrible thing. It's just, it's better to understand it. So probably not, but I might change my mind. All right. Again, because I want it to be fair to everybody. It's not going to be, anyway. So yeah, that's it for today. I'll see you guys on Wednesday for the test.